record. And we are on. We are live. Absolute values. Okay, so the absolute value of a number is denoted by the two bars, right, with the number inside. Distance is always positive, so basically that's the definition. It's like the distance from zero. That's what the absolute value is. It gives you your distance from zero. And as you know, in physics, distance is always positive, right? It's also called the magnitude of A, or how big A is in relation to zero, right? Its distance. If A is a positive, it remains positive. If A is negative, then multiply it by -1 to make it positive. Does that make sense? So if I have absolute value of -2, okay, absolute value of -2, how it comes out as 2. So really what we're doing is we're taking -2 when it's a negative and multiplying it by a negative to make it a positive. So are those equivalent things? Yeah. Okay. So do you remember when you have your two cases? And you have a case where it's positive, and so you just solve it. And then you have the negative case, and so you have to multiply by a negative. Right? That's to make it positive. And that's what we're doing in those two cases. So here, absolute value of 5 is just 5. Absolute value of -7 is just 7. Now let's look at this guy. Root 2 minus 1. Root 2, is that bigger than 1, smaller than 1? Let's think. What's root 1? 1. What's root 4? 2. So root 2 would have to be greater than 1. So it's greater than 1, so we know that this is going to be automatically positive. So do you need the absolutes? No. Okay, you know what pi is. If you don't, it's right there, or at least a portion of it. Right? So this is going to be a negative. So in order for it to to make it a positive, we have to multiply the inside expression by a negative. We're good, right? We get this. And that gives us simplifying pi, so that's equivalent to pi minus 2. Okay. All right. So simplify the following. It's a little bit different than what we're used to seeing, but we'll be okay. Is this in your notes? Okay. Oh. I'm missing page 18. There it is. Okay. All right, so -1, we want to take away the absolute values, right? So what do we have to times -1 by to make it positive? -1. Okay, I'm just going to write things out with. Does that make sense so far? Okay, good. Plus, now let's think about this. Root 16 would be 4. So this is a negative. So we're going to have to multiply him by a negative in order to make him positive. So I'm going to go minus instead, 3 minus root 17, because we're multiplying it by a negative. We clear with that? Or should I write that out differently? Okay, I'll write it out differently. Plus bracket negative times 3 minus root 17. Now it's equivalent to the above. Because in order to make it positive, we have to multiply by a negative, because it was already a negative number. Next guy, pi minus 2. Is there anything wrong with him? Is he positive already? Yeah. So we're just going to leave him as just pi minus 2. But keep him in brackets. Why am I keeping him in brackets? There's a reason. Because of the subtraction. Right? And it's a binomial. So that negative we're going to have to distribute. Because we're subtracting this whole thing. Okay? All right, so -1 times +1 is +1 times 4. 4. Okay, so this would become, bringing in this negative here, -3 plus root 17. And bringing in this negative, minus pi plus 2. Okay, good. All right, sometimes silence, I'm like, who knows what planet they're on right now. Okay, 4 minus 3 plus 2, 3. root 17 minus pi. So we're saying that this expression is equivalent to 3 plus root 17 minus pi. Do you want to double check this? Could you? Yeah. Now, scientific calculators, they should still have absolute value. You might have to find it. I do not have a scientific virtual calculator. Maybe I should get one. Maybe there's a TI version out there somewhere. Okay. So if I want to just double check that these are equivalent, then I stop. Put away Siri. Siri can't help you. You can try. I don't think Siri knows how to do math, though. Have you ever tried? So you can do some math, actually, basic math. Seriously. Yeah, let's do it after. Let's do this now first. Math, absolute value of -1 plus absolute value, which is math 1, right? Number 1. 3 minus root 17. Close the bracket for the absolute. Minus math number 1. Pi minus 2. We're saying, is that equivalent to 3 plus root 17 minus pi? Oops, not h. Pi. Yes, it is. Life's good. Okay? Cool. Moving on. So absolute value of A is absolute value of x is equal to A if and only if x is equal to plus or minus A. So let's what we mean by absolute value of x equals 5. So what could x be? Plus or minus 5. Pretty basic. Can be positive or negative. So we deal with two cases. So in a very basic situation, if you were solving this, this can be plus or minus. So we deal with two cases. So we're going to go with I'm just taking a real basic example that really can make sense in our brain, and then we'll apply it to a difficult example. So the first case is if it's positive. So if x is greater than 0, if it's positive, right? If the inside is above 0, or if x is positive. So then, if it's a positive case, then we could just say x equals 5, right? Make sense? The positive case. And then the negative case is when x is 0. So the negative case, so we have the positive case. When our inside is positive, when our inside is negative. So how do we deal with the negative case? If it was negative, what do you have to times it by to get rid of the absolute value? A negative. So we times it by a negative, and then solve here. You just divide both sides by -1. X equals -5. So you remember doing positive case, negative case. Willie? Can you put that on my desk? Wiley. Thanks. So what we're going to do today is we're going to just review a little bit of absolute value equations, and then we're going to apply it to inequalities. And we're going to take two things you know about, inequalities, absolute values, bring them together. Okay? Kind of a cool concept. 2x minus 7, the absolute value of that equals 11. So we have two cases, right? The positive case and the negative case. So case 1, it's positive already. So the positive case, what can we do with the positive case? Exactly. Just leave it the way it is. Get rid of the absolute values and figure out, okay, what's 2x minus 7? What would x have to be for that to be true? Okay, so we solve it normally. First step, algebra. Not just the underwear of a mermaid. Sorry. Okay, then divide by 2. You got it. X is 9. Okay, Then the negative case. How do we deal with the negative case? If the inside is negative, how do we make it a positive? Multiply it by a negative. So if the inside was negative, by multiplying it by a negative, it come out positive, which would be equivalent to my absolute value. Okay? Oh, you're trying to explain my joke? That's totally okay then. Oh. No? Oh. There's a fly there. There's no fly. I don't know. I think it is. It's under your clothes, under wear, what you wear. I disagree. Okay, let's not get into this. -7. 11 minus 7. 4. Divide by -2. X is -2. Okay? Do you want to try example 2 on your own? That was example 1. Why not? So break it into your 2 cases. You might have to be dealing with factoring and such. So yeah, x equals -2 and 9. Okay. On the other one? It's always, well, in this case it's not linear, so it wouldn't be a v. So it would, and then it's down 2. So it's like a quadratic, right? If we take the absolute value of a quadratic, the only reason why it's usually a v is you were taking absolute values of a linear equation. So a linear equation looks like this, and so then this part is reflected here. So if you take the absolute value of a quadratic, it's just making it a positive y value, right? But then we have that equals 2, and so it actually would shift it up. Or it's -2 down 2. It's like, yeah, it's a weird shape, right? Because we want the positive. And then the -2, as you subtract 2 over, then it just shifts like that down 2. So like, if I'm correct, I might regraph that. Okay, so you're dealing with a positive case and a negative case. The inside's positive, the inside's negative. Oh, you are looking for a solution.
Went in the wrong direction.
Okay. Here's how you should be starting out. Case 1, case 2. Right? Positive case, we just get rid of the absolute values. Negative case, we multiply what's inside the absolute value by a negative. Remember, with quadratics, you need one side equal to 0. So try it on your own first. And then when you're done, look at the front. yeah. Okay.
Minus negative 4.
Instead I brought everything onto this side to make the x squared positive. But you're welcome to do that, but then you're gonna have to factor it. The only difference would be you would have a it would look like this. You'd have to factor out the negative from those guys. Right? So you just have a negative in front of the bracket, which really doesn't change your solution. Yep. Well, or you would have one of them as like, you'd have to use complex factoring. It's not a simple trinomial. Right?
Yeah,
So
and then the x's represented.
you should still get the same 1 and 4, as long as you factor properly. Yep. You need to show work for both cases, yes. That you do need to show the work. Okay? Yeah. And remember, you can't solve this like in Math 30-1. You can plug this in, right? This would be left side, right side. Find the intersection. You can use your graphing calculators. Can we do that now? No. And that's why there's 4 solutions, right? When does it equal 2? So if we graph one graph and the other, there's 4 places. Yeah, that's why it's a belt, because of the quadratic. Okay. Moving on. Did everyone get that down? We're good to go? Okay, so we just need to get through this page. So here's where we're mixing, it's a little bit more of a more complex situation. We're dealing absolute values and inequalities. And that's when this is going to come in, great or less and. Because we have 2 cases. And so do we want the intersection of those 2 cases, or do we want the union of those 2 cases? Okay, so when it's great or is which? Is it intersection or union? Union, right, it's going to be the union. So when we have an expression of x is greater than 0, you're going to do your 2 cases, and we want the union of those 2 solutions. When we have the 2 cases of an absolute value, and it's less than 0, less and, then we're going to look for the intersection of those 2 cases. Okay, so that's where intersection and union come together. So here we have when is absolute value of x greater than or equal to a? So we're asking, okay, what numbers could we put in for x when we take the absolute value be greater than 5? Well, it'd have to be, if in the positive side, it'd have to be greater than 5, right? 6, 7, 8, 9, or smaller than negative 5. Negative 7 would, as an absolute value, become a positive 7. It would be greater. And so it's these 2 cases. We deal with both cases. Case 1 is the positive case. X is greater than or equal to 5, right, is case 1. Case 2, we take the negative. Now, what happens when you divide by a negative? You switch the sign. X is less than or equal to 5. And because it's greater, we're going to take the union of the 2. So it's both when, the solution would be when x is less than or equal to 5 or x is greater than or equal to 5. We take the union of the 2. So all values less than negative 5 or greater than positive 5, or equal to, oh darn it, I'll write it here. I just spelled greater wrong because I'm so used because of that. Equal to. So what numbers have a magnitude smaller than 7? It'd be the values between negative 7 and 7. So when we have less than, if I dealt with my 2 cases, you have the first case, 1, the positive case. X is less than or equal to 7. And then you have case 2, negative. X is less than or equal to 7. What does that become? X is greater than or equal to negative 7, right? We divide by negative 1, it flips the sign. And so here we have, in this case was x was less than 7. This one told us when x is greater than -7, and so there'll be the intersection when it's less than, less and. Okay, so it's going to be between two values. So let's try a problem like this. Solve the inequality of 3y plus 2, the absolute value of that, is greater than or equal to 4. Express your answer in interval notation. Okay, so we have two cases because we have an absolute value. So the positive case, okay, what do we do for the positive case? Just 3y plus 2 is greater than or equal to 4. Okay, let's solve that. Yeah. So like the or, so that we're going to use or means we're going to use the union. Right? Or is the union and is the intersection of those two cases. Okay, so let's solve this. First step. Getting y by itself, it's linear. So we first minus 2. Some of you are probably already done. Okay, 4 minus 2, 2. Then divide by 3. So y is greater than or equal to 2/3. Okay, that's now to go to case 2. Now, notice this is, when is y plus 2 the absolute greater than 4? So this is an or situation. Case 2 is the negative case. So how do we deal with the negative case? Times the absolute value by a negative. We get rid of the absolute value times what was inside by a negative. Now, right away, could we get rid of the negative? Question? We're good? Because here's my variable, right? And here's the absolute, and this is the greater or equal to 4. Yeah. Okay, so right away, can we divide both sides by -1? Yeah, what happens if I divide by -1? Flip the inequality. Good. Now it's a linear, so get y by itself. 3y is less than or equal to -6, so we get y is less than or equal to -2. So here, let's draw these out. We have a -2, and here's y. This is for y, and 2/3. Okay, so we're going to write it in interval notation. So when we had y is less than, remember there was an equal to symbol there, or equal to -2, and y greater than or equal to 2/3. And we want the union, so everything that's, so what's our answer? All of this and all of this. How do we write that? Remember we learned that yesterday, the new way to write domain or range or whatever. So it goes from -∞, comma, -2. Oh, close. Thank you. Okay, bracket should be, because of the equal to square bracket, then, thanks Greg, union, closed, open bracket. Beautiful. Fun? Yet? Yeah? It's kind of cool. You know, just turn your page, draw an H, turn it back. Okay. So let's try another one. This one is a quadratic. Quadratics, remember when solving inequalities with quadratics, we had to do test cases. So there's going to be a little bit more work here. Okay, so let's try this one. And then that's it for today. Yay! It works out well as a Thursday. I'm moving your exam, and I'll talk about that after, okay? Okay, so when we see an absolute value, we have to deal with two cases. Now, is this an and or an or? And. It's going to be an and. That's what you meant. Okay. So, two cases. First case. Let's deal with the positive case first. Be consistent. Good? Did you guys want to try solving this part on your own now? Because this is from yesterday, right? After we get rid of the absolute value. Did we not do this yesterday? Did anyone do their homework last night? Let's be honest. Some of you? No, so you're not. Luckily, we had no quiz today. So yesterday, what did we do when we have a quadratic and we're solving equalities? Or whenever you're solving a quadratic? Linear, we want the variable by itself. Move everything to one side. So in this case, take away 2. X squared plus x minus 6 is less than 0. Now what do? Factor. Two numbers that multiply to negative 6 and add to positive 1. 3 and negative 2. So what are these going to be called? We've had a special name for them. CVs. Yeah, they're CVs. What does CV stand for? Critical values. Yeah, our CVs are critical values. The places where it changes from a negative to a positive in each factor are going to be what? Negative 3 and positive 2. So here, I'm going to show you how to do a number line, the interval test, without drawing the chart. Is that okay? Okay, saves time. Negative 3, 2. It's really easy. We test each factor. I think I showed you this yesterday. So pick a number less than negative 3. Negative 4. So I test first. This guy is going to be negative 4 plus 3 would be a positive or a negative? A negative. And a negative 4 minus 2 will be a negative. And so the product of these two would become a and I'll write the positive on top. So there's my product. So together a negative and a negative will give me a positive. Yeah? It's true, right? It's a quadratic, so what's this going to be? Negative, and what's this going to be? Positive, and you can check it, right? 0, positive and a negative, and then here positive and a positive is a positive. You can do the check really quick. Okay, so now when do we want? We want less than 0. We want the negative case. So that's going to be between negative 3 and 2. Here. Between negative 3 and 2, right? That's this part. Now that's not our final answer. That's just for that case. We have an and situation. So we're going to intersect this answer with this answer. And that will be our solution to this problem. Okay, great. It is great. It's so cool. Sorry, I'm a nerd. Okay, negative case. Greg, what I do for the negative case?
You multiply it by a negative.
Bingo. Multiply who by a negative?
The absolute
The absolute
value.
value. Now, to make life easier, could we just move that negative to the other side? Yeah, what would happen with our inequality? Flips. So we divide by negative 1. Okay, now what? Because we have an x squared. Move everything to one side. First, move everything to one side, and then factor. X squared plus x plus minus 2 When is that greater than 0? Two numbers that multiply to -2 add to +1. -1, +2. Okay? Yeah. Yeah. So what are our CVs? Nope. 1 and -2. Okay? So let's do a little interval. We have a -2 and then 1. Oh, that's our function, actually. Okay, so here, pick a number less than -2. -3. Okay. -3 minus 1 would be a negative. -3 plus 2. No, would be negative. 2 negatives, positive. Okay, so what would, because it's a quadratic, what's happening? Negative, positive, you can check your answer. So I could use 0, be a negative times a positive, and then here will be a positive times a positive. Okay, so we want now this time, what is this function greater than 0? So there's here and here. Okay, so we want the intersection of these two solutions. So right now it's, this part was negative infinity to -2, 1 to infinity. Remember that it's open because the original inequality has no equal to symbol underneath. Okay, so we're going to, easiest way to figure out the intersection is just draw it. So draw both of them. So we need to put all our critical values that we had before on our new number line. So our critical values before, we had a -3, there was 2, there's a 1, and there's a -2. And we want to find, and are we want the overlap or do we want everybody for and? Just the overlap. So here, this guy was between -3 and +2. And this guy was less than or equal to -2 and greater than or equal to 1. So where's our overlap? Yep. Oh, thank you. Greater, just greater. Because of there's no equal to sign there. Okay, so our solution is, where's the overlap? Open. The union? No, we're doing the intersection. Our final answer will always be union, right? Because it's this and we want this or this are the solution. So always our final answer, when there's two separate parts, we'll have union. Just when solving it, we had to use the intersection. Okay, so you'll never have an intersection in a final answer. Beautiful, beautiful. That was fun. Okay, that is today's lesson. Tomorrow's quiz will then have a question that's just an inequality solving and then an absolute value inequality. So two parts, those two questions. Okay, so a question, well, let's open up your homework and I'll show you. Let's stop the recording.